In the following video, we're going to look at a second example of solving a system of equations in three variables that has one solution. Again, the key to doing this correctly is to take your time, check your calculations for small mistakes, and to organize your work. So remember the advice I gave in the previous video. You have three equations. You have three variables. So you do the elimination method 3 times. 3, 3, 3. So let's figure out how we're going to structure our work, which variable we're going to eliminate first. So I have 2x, negative 3x, negative 5x. Doesn't look very easy to eliminate. 4y, 5y, 3y. Doesn't look too easy, but if I look at this third one, negative 5x, 2z, and negative 1x, well, if I pair up the first and last equation, I have a negative 5z and negative 1. If I multiply that bottom equation by negative 5, that gives me a positive 5z, which would eliminate z. If I pair up the second and third equation together, I have a 2z. If I multiply the bottom one by 2, that would give me my negative 2z. And so I'm going to choose to eliminate the z. And again, I'm going to try and color code my work so it's easier to follow. So when I match up the top equation of 2x plus 4y minus 5z equals 18, and the bottom equation of negative 5x plus 3y minus z equals negative 17, I said I'm going to multiply to eliminate a negative 5z here, multiply the bottom equation by a negative 5 to create a positive 5. So negative 5 here, distribute to all the terms. So the top equation stays the same, 2x plus 4y minus 5z equals 18. The bottom equation, multiply by negative 5, you get a positive 25x. You're going to get negative 15y. And again, look, x above x, y above y, we see it's being organized. And then a negative 1 and negative 5 gives me a positive 5. And then negative 5 and negative 17 is going to give me a positive 85. And so what I'm going to do is, since I have opposites, add the two equations together. The negative 5z and 5z will cancel. So the new equation I get that has only two variables, the x and the y, is 27x minus 11y equals 103 by pairing the first and third equation. So for step 2, we eliminate the z again. We want to create two equations, a new system that has the same variables. And so that was what I marked in green here. I'm going to keep the second equation as is of negative 3x plus 5y plus 2z equals negative 27. Now the bottom equation of negative 5x plus 3y minus z equals negative 17, I said I'm going to multiply by 2. That will give me a negative 2z here to eliminate the z. And so I keep the top equation the same. Negative 3x plus 5y plus 2z equals negative 27. Now I'm going to double everything in this bottom equation. So I get negative 10x plus 6y minus 2z equals negative 34. I have my opposites, so I can add the columns together. 2z and negative 2z will cancel. Negative 3x and negative 10x is negative 13x. 5y and 6y is plus 11y. And negative 27 and negative 34 is negative 61. So I have my first equation with two variables. I have my second equation with two variables. So step 3 is to match up these two new equations and eliminate one of those variables. So if I take a look, which one am I going to eliminate? 27x, negative 13x. Well, I'm going to go and tell you, you're going to have to multiply that top equation by 13 and that bottom equation by 27 to eliminate the x. That's large numbers, a little more difficult. But if I look at my y, I see I have negative 11y, positive 11y. They're already opposites. So I'm just going to leave them as is, and I'm going to match them together to create a new system. And we're going to eliminate the y because they are already opposites. So let me give me some room. And again, I'm going to color code the equations so we can go back and check all of our steps. So this one should read 27x minus 11y equals 103. The other equation is a negative 13x plus 11y equals negative 61. They're already opposites, so I'm just going to add them as is to eliminate the y. So 27x minus 13x gives me 14x. And 103 minus 61 is 42. Divide both sides by 14. I see that x equals 3. So I now know x. I can plug it into either equation, the 27x or the negative 13x, to solve and get y. So that was our step 4. Our step 4 is to substitute in to find y. Now it doesn't matter which one you use. I'm going to go ahead and use my 27x one. So I have 27x minus 11y equals 103. And I told you that x was 3, so you're going to have 27 times 3, which 27 times 3 is going to be 81. So you have 81 minus 11y equals 103. Subtract 81 from both sides, you get 11y equals 22. Divide both sides by negative 11, y equals negative 2. And so then there's my y. So I now know x. I now know y. Step 5 is to substitute and to find the last variable of z. And so I can use any of my original equations. I am going to use the last one that we had, which was negative 5x plus 3y minus z equals negative 17. I saw that x we found was a positive 3, so I'm going to have negative 5 times 3. My y was a negative 2, so it was a negative 2, so 3 times negative 2. And that's going to give me negative 15 minus 6 minus c equals negative 17. Negative 15 minus 6 is negative 21, so I have negative 21 minus z equals negative 17. Add 21, you get negative z equals positive 4. And then when you divide both sides by a negative 1, you get z equals negative 4. And then write your answer as an ordered triple of x of 3, y of negative 2, and z of negative 4. Again, look at the way that we organized our work. We took our time when multiplying, made sure we went to every term. We organized it so our x's are above our x's, our y's above our y's. We organized it so we could see each step and structured it for it, and then took our time plugging our values back in. That is the key to solving a system of equations in 3 variables: organization, structure, and taking your time.